Okay, so we're back, and today we're going to continue on. So I'm going to do a video, but before I do that, look what I got. So can you guess what today is? So I got this today. So yes, I'm recording this video on Valentine's Day. Valentine's Day. Woo. Okay, anyway, I'll eat these later, or I'll give them to my kids. Okay, so today we're going to go over the standard form of a line, the standard form of a linear function. So standard form, by the way, standard form, the definition of standard form really isn't standard. It changes from textbook to textbook. For this class, for this video, we're going to use this definition as standard form. So A, B, C. So AX plus BY equals C. Okay, now, one of the things that we're assuming here is that all of these coefficients, the two coefficients here and the constant, have no common factor other than 1. Okay, so we call that relatively prime. So anytime we, excuse me, where the greatest common factor among 2 points, or excuse me, 2 numbers is 1, then those 2 points are relatively prime. So this is what we want. If it's in standard form, we're going to want to make sure that these are relatively prime. They have no factors other than 1, right? In common, no common factors other than 1. And so that would be standard form. So that's it. Okay? So now, let's do a graph and say, okay, I want to graph this function, or this line, this equation, this function. So now, it's in standard form, so how would we do that? Well, we're going to find the intercepts. So let's find the intercepts. So the first one is, let's find the y-intercept. Okay, so we're going to set x equal to 0 and solve for y. So we have 4 times 0 minus 4y equals 0. Well, that's going to give us what? Negative 5y equals 0, because this is just 0. And well, what do we get? We get y equals what? Well, 0 divided by negative 5 is 0. So guess what? The y-intercept is right through the origin. Now, since this is a straight line, this is also going to be the x-intercept. Okay? Because if it's a straight line, it can only go through a point one time. Okay? But let's prove it to ourselves. So let's do the x-intercept, just to prove it to ourselves. So now we're going to set y equal to 0. So we're going to take 4x minus 5 times 0 equals 0. So again, this is going to be 0, and so we're going to get 4x equals 0. And again, if we divide both sides by 4, we get x equals 0. And so again, we get the x-intercept through the origin. So there's 1 point. So now in this case here, guess what? Normally we would want to normally the intercepts are different points, right, on the graph. In this case, it's the same point, so we're going to need an additional point to sketch the graph of a line, a straight line, a linear function. So let's pick a number. So how are we going to find that? Well, let's put in 5. Okay, let's do something easy. So let's put in x equals 5 and see what we get, right? Because if we put in 5, then that'll give us a corresponding y value. So let's do that. So we're going to need an additional point, so let's just pick a point. So let's take 4, and let's stick 5 in here. Let's do 5. 4 times 5 minus 5y equals 0. So this is going to give us 20 minus 5y equals 0. We can factor out a 5 here, right? Let's factor out a negative 5. So that'll be negative 4 plus y equals 0. Well, if we divide both sides by -5, well, the -5 goes away because 0 divided by -5 is still 0. So now it becomes -4 plus y equals 0. And now I just add 4 to both sides, and I get y equals 4. And so now the point that I'm going to plot is 5, comma 4. So if we go 5, 4, my other point is going to be right about here. And so now what I'm going to do is I'm going to connect the dots. And there we have it. Okay? And that's how you graph a line that's in standard form. That's it.